welcome back to my Heathkit AA 100 restoration channel. This amplifier came in from a customer in Florida, and he's asked that I do a full restoration on it. Now, this is a very good looking amplifier. I mean, I'm seeing all the knobs are here, everything looks great, and I'll show you the insides here in a second, but this amplifier is absolutely bone stock standard, and I don't see that it's ever been messed with as far as I can tell, except maybe a tube replacement. So let's take a look inside. Everything to me looks like it's bone stock original, which is great. The preamplifier board looks good. I don't see any problems here on the top side. That's not to say there's no problems underneath, but we'll get to that in a minute. I do notice that it has the original output board, which, as you know, if you know these amplifiers, these things are terrible. They always fail, and they're in really ratty condition by the time they get to this age. So the customer has asked me to replace this board with one of my new AA 100 boards. This is a board that I created back in 2016 to repair my own amplifier. So many guys asked me if I could make them some too that I ended up making a big long batch of these things, and so we're still working through that batch, and he's asked me to put one of those in there, so we'll do that as well. Now the tubes, he asked me if I would replace all the tubes, and I said, wait a minute, let's find out what shape the tubes are in before we do that, because sometimes those old tubes can still be in great condition and sound really good. So just taking a quick look in here, I've got some Raytheon tubes, I've got RCA tubes, that's a GE tube, and these over here. The output tubes, the 7591s, it's interesting because there's no brand on them anywhere. All it says is 7591, and that's it. There's nothing else. So it's possible that these tubes may still be in good shape. So let's go ahead and test these and find out what we have. Before we get too carried away, I forgot to show you the bottom. Now, if you look here at the output board, you can see 4 very dark spots. That's where the output tubes are, and there's so much heat there that that heat just cooks the circuit board. And I've seen all kinds of problems with these things. But we'll be replacing that, so it doesn't matter. We have the original capacitors here, all the resistors look original. We still have the original selenium diode. Now these things can be trouble because if that diode quits, that means that your negative supply also stops working, and that will allow your output tubes to run away, and you could get a red plate condition and subsequent destruction. So we need to make sure that these things get replaced with modern silicon diodes. Hey guys, check this out. This EF86 tube here says Heathkit by Millard, made in Great Britain. Now that's really something. I'm going to take you through one tube test procedure, and then I'll perform the rest off camera unless we come across something interesting. So the first thing I want to do is get the tube in here and get the power on and let it warm up. So this tube has been in here for a couple minutes, and I can feel the heat, and I could probably see the filaments if I looked hard enough, but I can tell that it's working just based on the heat that's coming out of here. So we know the filament is good. Now I want to do leak checks. So I'm tapping the tube and rotating the dial, looking for any kind of movement on the meter. If the meter snaps up, then I know that there's a shorted element inside there, which makes the tube no good. Okay, so that looks great. Now it's time to test mutual conductance, which is the actual performance of the tube itself. So I do that by pressing the GM button here, and I have 650. Now the minimum on this tube is 300. We want to see something that's much stronger than that, because if you come down to 300, that means the tube is really marginal and it's really time to replace it. But 600 is a really good number. Now I've set the tube tester up to measure gas. And I do that by pressing this button here, and the needle moves upscale to a calibrated position. When I press the other gas button, we're going to see a little bit of upward deflection, but anything less than 2 divisions is actually acceptable. So let's go ahead and push it here. And see, we have a very, very minor deflection upwards, so that means the tube is not gassy, so that's good news, and we passed the test. Now I'm going to perform a life test. So I go ahead and push the mutual conductance button again. Let me just readjust this briefly here. Now I'm going to press the life test button. And what that does is it cuts down the filament voltage to see if there's enough reserve emissions to keep the tube going with less filament voltage. And it's pretty typical to see the needle swinging downwards a little bit. And as long as the needle doesn't go below mid-scale, then you're good. See here, we have a really good strong tube. So this EF86 so far is in great shape. All of the tube testing is done now, and I've got some good news and I've got some bad news. Now the good news is this amplifier here is probably one of the best looking amplifiers I've seen come through the shop yet. It's in absolutely pristine condition and will make a great candidate for restoration. Now the bad news is I have the tube test report right here. All I can figure is that whoever owned this amplifier all those years loved it to death and just played it and played it and played it and played it, because I've never seen tubes this worn out ever. So I'll have to deliver the bad news to the customer, and maybe it's good news in disguise, because when we get done here it'll have a fresh tube complement. Now the EF86 tubes that run the phono preamp, they're absolutely perfect. They're pristine, very strong, so those tubes will leave in place. I had a phone conversation with the owner, and he's approved the replacement of all the bad tubes. So it's going to be an expensive fix, unfortunately, but that's how it is sometimes. You just never know with these old amps what shape the tubes are in. So what he wants is a full electronic refurbishment. And so what we'll be doing is we're going to be taking these controls out of circuit because they only add noise and they don't really have any useful function in today's world. We'll be rebuilding the electronics in the power supply completely. That involves replacing the CAN capacitors, all of the resistors down in the power supply. This entire board is coming out, of course, and this board is going into its place. That takes care of the output section, brand new tubes there. And the preamplifier will be replacing all the old capacitors and all the old resistors. We're going to use tight spec, really high performance parts, and that's really going to open up the sound and give us a very, very clean audio. I know this because we've done this many, many times, and we get great reports from customers back that they're just blown away by how much better the amplifier sounds when all these things are done. And here's the thing, when you take these old transformers and you surround them with really good electronics that are in top condition, this amp is incredible. So we'll be doing all of that, and the switches will remain the same, although we'll clean them. The controls we'll clean if necessary. He wants me to relamp this. Now, I've never had anybody ask me to put LED lights in an AA100, and there's a good reason for that. It just looks cold, right? So we always try to go back to the original number 47 lamps that have that warm glow that we all have come to love. Another thing that I believe is an absolute must is to replace the power cord. I always take these out and I put in grounded cords, and I do a special modification to the amplifier which makes the entire chassis sit on ground, and that acts as a shield and keeps noise out of it, and it really helps to clean things up. Now I need to start taking wires off of this board so I can remove it. So I'm starting with the filament voltage wires. All right, here's the DD wire pair, and here's the EE wire pair. These are your filament voltages to the board, so those come off. That's our 6.3 volt. We have our audio wires, which come from this board to this board through a set of potentiometers. We need to take those off. So let's see where those go. This capacitor is broken. That's interesting. Okay, so these go here. I believe that is called A and B. Now, the unfortunate part about the AA100 and changing out the board, and I've never liked this, but there's nothing really we can do about it, is the thing is pinned down by all these transformer wires that go across here. So these all have to be removed from their terminals. So the way I recommend that we do this is to take off one at a time. Now make yourself a label with some tape. Label that wire so that it goes back exactly where it came from when you put it back together. So that was left channel 16 ohm terminal, and I put a label on there so that I know exactly where it came from. I'm going to go ahead and work on these off camera, and then we'll come back in a while. This looks like a bad day in the operating room, but it's absolutely necessary because all of these wires have to come off of the circuit board, and all the hardware that's used to hold it on has to be removed. Now once it's clear, we can go ahead and start working it loose. I like to pull up the side that's on the transformers first, and then very gently try to tease it out of there. I think we have a capacitor or something sticking up. Let's move this over a little bit, see if that helps. Let's see here. If I can just get that clear of the fuse holder, I can slide it down and then maybe get it to come up. There we go. It just takes a little bit of work. Now I still have some wires on the other side that need to come off. And when you're taking the wires off, don't forget to remove the wires from the front side like I did. This is the old circuit board that I took out. This thing is so ratty. The components are 50 or 60 years old, not exactly sure. The resistors are carbon composition resistors, which are extremely noisy. The capacitors are probably old and leaky. And all around, this is really just not a good thing. Aside from being dirty, it has some other problems too. First of all, it's a one-layer board. It has absolutely no audio shielding. It's badly warped. It's also broken. You can see it's broken out here and it's chipped out here. They weren't very durable. Let me show you the back side. Here you can see the traces are run all over the place. With a two-layer board, it's much easier to get from point to point without doing the scenic route. So we cut down the length of our traces on our new board and made it much better. This is one thing I really wanted to point out, is look how burned this thing is. That's the heat from the output tubes. There was just no way to dissipate that heat because they had plastic sockets and basically plastic circuit boards. So the new ones are much better at dissipating heat. That capacitor is broken too. That's interesting. I'd like to do a side-by-side comparison. This is the original circuit board that came from the factory, and this is my circuit board, which I completely redesigned based on this design, only better. So you'll see the ceramic sockets here. These are really great at dissipating heat and getting them away from the circuit boards. Secondly, the circuit board is made of fiberglass, not phenolic, and it's also two-layer, and so that lends itself really well to doing proper shielding and keeping trace lengths as short as possible. Alright guys, it's time to transplant the new circuit board in. So I have my little spacers that came out. I'm putting them back in where they were. Now sometimes you might get a tube that's too tall and you can't put the cover back on. The way to solve that problem is to change these spacers out for ones that are a little bit larger. But I'm putting the original ones back on as they came out because that seems to work pretty well with the tubes that I use. You'll notice the circuit board has the keys in it, which are exactly the same as the originals. So we'll flip it upside down, and I'm going to try to put it in exactly the same way the other one came out, just staying back away from the corner a little bit at first, and try to get it down under the chassis. You kind of have to play with it a little bit. Make sure that you don't pinch any wires anywhere, but it should just basically just kind of set right down in there. Okay, I suspect that either this stud or this stud is bent, so I'm going to go ahead and try a test. First I'll put the standoff on, And then I'm going to take a mechanics square, just set it in there, and just park that right up against there. And looking at it, I can tell that it's straight up and down, so it is square. So it's not that stud. Put the mechanics square in there and check it out. And yes, I can see that the stud is bent this way, slightly. So let's see if we can fix that. Okay, I'm going to put a pair of pliers on here and just gently nudge it over a little bit, and then remeasure it. Okay, it's better. Okay, I got the board on there, but I had to fiddle with it a little bit and kind of nudge these sideways just a little. Modern manufacturing is incredibly precise, but this was made in 1963, and tolerances weren't really good in those days, not like they are today. So the circuit board is perfect, everything else around it is not so much. Now I'm going to go ahead and start putting the hardware back on and get this thing back together again. I'd like to point out a couple of things here. This is the phase reversal switch, and there is no good reason why we would ever want to reverse phase on our stereo audio. This harkens back to the days when everything was experimental and people didn't really know what they were doing. They were trying to figure out how to make audio work, and sometimes you get phase reversals in equipment. Well, we don't do that anymore. Our phases are always in phase, so you would never ever have to use this switch. It's a point of failure, and so I went ahead and bypassed it. The other thing I'd like to point out too is the wiring here was a real mess before, and I went ahead and pulled those old wires out and put some new wires in here and dressed them nice and neat. So you can see this whole area here is looking really nice. Those of you who are familiar with my work know that aesthetics is everything. So I see all these wires just running around willy-nilly all over the place, back and forth across the top. There's no reason why those wires can't go underneath where they're concealed. So I'm going to go ahead and do that. Most of those wires I just showed you are filament power. They power up the filaments on the output board and the preamplifier board, but it jumps from the power supply to here and then over the top and over to the preamp. Well, what I did is I made myself a new twisty wire, and I'll demonstrate that in a minute. And I went ahead and I connected it here. Instead of going over the top, I routed it along the side underneath, and I just left it here as a pigtail for now. And then when I get in here and work on this section here, I'll go ahead and connect the filaments at that time. So I have to do this twice, once for this side and once for that side. This amplifier has a hum balance circuit. The way that works is the AC voltage, which is 6.3 volts, comes off the power transformer, and then it goes across a potentiometer that has a small network to ground. And what we have to do is take the two outputs from that potentiometer and run it over to the board. I don't like the way that they ran this one, so I'm going to run a new one. So I'm basically just going to kind of eyeball it here, see where it's going. And then I take a couple inches more, and then I cut this wire. This wire, by the way, is just basic doorbell wire. It's inexpensive. It's the same gauge as what's in the amplifier already, and it works really well. Now, I'm going to take my drill and open up the chuck a little bit, stick my wires in there like that. You probably think I'm out of my mind, but watch this. I'll put this end in pliers and then just pull down on the trigger. Watch what happens. Pull it tight. Look at that. I've got a beautiful twisted pair. Now, what I'll do is I'll untwist a little bit here and I'll connect it. I'll run it down there and then I'll connect the other end after a while. So let's go ahead and untwist this just a little. We want to keep the twist in there because it helps to reject hum. So I'm going to strip this. And because this is AC, it doesn't matter which one goes to which one. But for aesthetic purposes, I think I will keep the red on one side and white on the other to match up with the other cable that's there. Now, whoops. These things don't want to stay put. Okay, I think I've got that. Let's go ahead and solder that up now. We're going to go ahead and run it across those to reduce any possible inductive pickup. And then I'll tuck this in back here. See if I can't get that to lay down nice. I've got a bajillion wires here I have to get around. But you know what? If you do a nice job, the amplifier not only looks good, but also works good. Okay, so I'm just going to leave this pigtail here for now, and I'll connect that up later. So what I'm doing strategically is I'm working my way down the circuit board here until I get to here, and that's as far as I can go until the parts arrive. Once I have all my resistors and capacitors on hand, then I can start rebuilding this section and this section. Hey guys, I'm back. I have a bad habit of working and not filming, so I thought I'd better stop down and catch you guys up. So here's the old rotten output board I took out of here. It's got broken parts and it's pretty ratty looking. I have a brand new circuit board sitting in here. It's partially wired up, and I've replaced a lot of the wiring because it was old and ratty. Now we're really at the scary part of the process. So it looks pretty clean in here, and the reason it looks clean is because I ripped all of this stuff out. These are the input-output jacks. We've got the input level controls. All this stuff is coming out so that I can rebuild the circuit board back here. I'm going to be replacing all of the resistors, all the capacitors, and then I'm going to clean these up and put them back in, except this time, instead of twisted wire, I'm going to use thin coax and see if we can't clean this audio up just a little bit. The other thing I'm doing is I'm bypassing all these input level controls because look at that, they're open frame. You know that these are going to be noisy. And why do we want to introduce noise into our audio path? So I'm taking these out and bypassing them. They really aren't necessary, and it does a lot for cleaning up the sound. So I will be putting them back in mechanically. They'll be there. If some future restorer ever thinks it's a great idea to put these dirty old pots back in the audio path, God bless them. But for now, we're taking them out. I just want to show you how extensive this restoration is. I've got brand new CAN capacitors. I've got, I'm not sure exactly what that is, but it's probably some kind of capacitor. I've got piles of resistors, capacitors, all new tubes, more capacitors, coaxial cable, and I'm also in the process of replacing the power cord, which I do to all the amplifiers that come in here for safety, and it also puts the chassis on ground, which acts as a nice shield, and it cuts down the noise. But I just wanted to show you how extensive this is going to be. Normally I don't replace a bunch of tubes. I like to replace them on condition. If they're bad, great, I'll replace them. If they're still functional, I like to leave them in place because we don't want to waste good tubes. Now, of all the tubes in this amp, only these two here, the EF86s that are used in the phono preamp circuit, these are the only two that were any good. All the rest of them were bad. I've never seen that before, but there's a first time for everything. I've been unsoldering like crazy trying to get these components replaced. I did a couple here in the corner and I realized that I might as well just rip them all off. So I went ahead and took everything off this board except the sockets, the networks, and the switches. The networks can't be replaced, the switches can't be replaced, and neither can the sockets. Well, they actually can, but I've chosen not to because they look really good. Well, this is the point where everything is kind of scary because it is really torn apart right now. All the components I ripped out, look at this. These are the components that I ripped off of the preamplifier board. I've got old resistors, I've got old capacitors. Do you think these are going to sound very good? Probably not. But we have new parts in there, or at least new parts are on the way in. I went ahead and replaced the resistors here. I haven't yet soldered them. So that's the next thing. So I'm going to turn this thing around. I hope you can see it there. There's a forest of leads, and every single one of those has to be soldered. I am running out of solder at this rate. So let's just go ahead and solder up a couple of these. I know you guys don't want to watch me solder all day, so we'll go ahead and cut here and come back later. Now there's a lot of modifications that have to be done to do what I'm doing here, and it does require a good deal of skill, at least to be able to read the schematic, interpret what's going on, and have a plan, because there's a lot of things that can go wrong with this if it's not done well. Here's the old output board. Here's the new output board. Things are looking pretty good there. And here you can see all new components on the preamplifier. So having this brand new is great, but having this brand new is awesome. It just really makes the sound clean and clear. Now, the grounding on this amplifier is significantly better than it was. The way it came from the factory, well, I guess the factory being somebody's kitchen table, the grounding really wasn't that great. And so I've cleaned that up, and I'm expecting this amplifier to be nice and quiet. Now, a note about standing this up. You probably noticed me standing it up most of the time. You can stand it on its side as long as you use the side that has the power transformer down, because it will stay, and it's very stable, as you can see. I don't recommend doing it the other way with the output transformers because it's not very stable. So now, everything's done. But here's the thing about this amplifier and all the work I did. I've done so much, replaced all these parts, replaced a lot of wiring, made some modifications to clean it up and make it sound better and quieter. This is essentially a brand new amplifier that's never been turned on, and we don't know what's going to happen here. So I'm going to be very slow and deliberate about how I power this thing up. Let's get the meter set up here. That's 120 volts AC, actually 200 range, but I want to go through and I want to check the power outlets here and make sure that I've got what I think I'm going to have. So this back here is the normal. So I should be seeing about 120 volts right there. I've got 118. Well, I had something there. Hold on a second. And this one here is switched. I should have had nothing. And I have nothing. Okay, well, we have power at least to here. So I'm going to go ahead and turn the switch on. Now, all the tubes are out. The high voltage rectifier is out especially. I'm going to turn this on and see if I have 6.3 volts for the filaments. If I do, then these front panel lights will come on. If I see nothing at all, if I hear something strange, if I see smoke, anything unusual, I turn it off immediately. That looks pretty good. I've got the lights on the front, although two of them are burned out apparently. So let's take a look at that. We should have about 6.3 volts. It may be a little high because the tubes are out, but we should have somewhere about 6.3 volts. Let's see, turn this around so you guys can see it. And let's see what we get here. 6.8. Okay, yeah, it is just a touch high. But once we put the tubes on there, that should load it down to about 6.3. So I'm going to make a mental note here. We need to change these light bulbs. Two of them are still good, but I'm going to go ahead and change them all out just to set everything and refresh it so it's good to go for another 20, 30 years. One of the most important tests before I proceed any further is to make sure that the bias supply is working properly. The bias supply gives us a negative voltage, and that negative voltage is used to throttle down the 7591 output tubes and keep them from running away. So I should expect to see somewhere around negative 20 volts, give or take a few. So let's go ahead and get the probe on here and see what we've got. We've got negative 23 volts. That's actually very good. I've seen that number vary quite a lot from like 18 to 22, actually 23. This is the highest one I've seen yet. But that's good because the more negative voltage we have, the more room we have to throttle down the tubes with the bias controls. So 23, I'm going to call that a success. Now the next thing I want to do is get in and start testing the high voltage power supply. But this supply will put out in excess of 500 volts if it's unloaded, and that's not good for the capacitors. So what I'm going to do is take the old output tubes. These tubes are flat, but they're still functional, but they're not good enough to be used in everyday service, but they're great for loading the power supply. So let's go ahead and put these in. This is the rectifier. Okay, that should be sufficient to load the power supply so we don't burn our capacitors up. I'm going to turn this on, and I should expect to see about 450 volts-ish. Let's make sure we're on the right range. So let's go to 600 volt DC. And as I go step by step through the power supply, I'm going to see different voltages that continues to stair step down as I go across the resistor ladder. All right, let's turn this on. I've got to be real careful I don't short something out or zap myself, which is a good time to talk about safety. Like I said, 500 volts is inside here. You do not want to get across that 500 volts, I guarantee you. I've done it, and it hurts, and it can also be lethal, so be very careful. All right, let's give this a moment to warm up. We should have some power now, so let's see how many volts we have on the first power supply stage. It's 380, 400. It's still warming up. 330. I'm expecting to see about 450. 442. Wow, 450 right on the money. It may come up just a little bit, so let's keep going. $389, okay, good. 367, good, good. 312. 218. All of the voltages are looking great. They're very consistent with what I see on other amps that I've done, so the power supply section is working great. There's only one thing left to do, and that is to turn it off and put some tubes in. Now comes my favorite part of the whole process, and that is putting the tubes back in and turning it on and seeing what it does. So we'll go ahead and start with the rectifier, which is a GZ34. This is a brand new Mullard reissue. The base is a little bit different than what I'm accustomed to. Made in Russia, okay. Historically, their quality has been very good. I do hope that they get their wits back about them again so they can keep supplying us with tubes. Now, let's do the output tubes, the 7591s. These are tongue saw, and it doesn't say where they're made, but maybe it says so on the tube itself. Tongue saw, made in Russia. I'm a little concerned about these tubes possibly being too tall, because they do stick up above the transformer just slightly. That may be a problem. If that is a problem, we'll have to replace the standoffs that hold this circuit board in. Okay, these are new old stock 7199s that I bought, and they do test good, so we'll be all right with these. I gotta say, these new ceramic sockets, they are tight. But that's a good thing, right? Okay, these must be 12AX7s. These are also Millard reissues, probably also made in Russia. A clever bit of marketing to use an old British name. Okay. Okay, these are the original EF86 tubes. These two tubes are the only tubes in this entire complement that were any good. So we'll be reusing these. The EF86s, they have shields, but I'm leaving them off for now. I'll put them on before we get finished here, but right now I just want to see what the amplifier will do and make sure it functions correctly. I was just admiring this. That is a good looking amplifier. All those shiny glass tubes and black transformers, new can caps, everything. That's wonderful. The first thing I'm going to do before I power this up is I have 4 bias controls that are on the new circuit board. I want to take those controls and I want to run them all the way down counterclockwise. Now these are 25 turn trimmer pots, and so you're going to have to turn them down quite a number of turns until you hit bottom. And don't worry about going too far because they're protected against that. You can just turn it forever and ever and it won't go any further. But make sure that they're set down as low as possible to start. Oops. The reason we do this is we don't want these tubes to go into a red plate condition when we first start it up. Now it's time to calibrate. So I have all my tubes in. I have my meter here and it's set for millivolts, not volts, but millivolts DC. And I'm grounded to the chassis. So I'm going to take my probe and I'm going to find the test point, which is down in here. Let's go ahead and turn the amp on and get it started to warm up. I'm on my first test point and I'm going to go ahead and adjust this up until I see 32. Okay, there it goes. All right, let's get the next one. It's about 32. I'm seeing a lot of bouncing of the numbers here, which makes me think there's some kind of electronic noise going through the amp right now. So we'll come back and address that later. I just want to get the tubes balanced up as much as possible before we start. All right, that one's going down to about 36. So let's see if I can get the rest of them to match that. Okay, they're all matched to 37, which means that they're all biased the same, they're all pulling together the same amount. It's like rowing a boat. Everybody wants to row at the same rate, the same speed. This is where things usually start to get interesting. I've got the amp hooked up to the speakers, I've got the turntable connected. We've had it powered up and nothing bad has happened, but I have no idea what condition the switches or the pots are in. And frankly, I don't know if I did this correctly. I've done this many, many times, but you know, we are human and mistakes could be made. So let's go ahead and turn this thing on and see what happens. Well, the first step is plug it in. Now that this amplifier has been modified for grounded power, you need to make sure that you're using grounded power to power this amplifier. And since my house is very, very old, I have to choose carefully where I get my power from. All right, so you see I replaced all the lights. So far all I hear are just the tinkling of tubes as they heat up. Well, so far so good. Let's crack the volume and see if there's any residual noise. It's dead quiet, which means one of two things. Either it's working great or it's not working at all. Well, if I run it all the way up, I hear a slight hum there. I don't hear anything over here. Let's go ahead and play a record and see what it does. Well, I hear absolutely nothing. So we do have a bit of troubleshooting to do. So let me just run the selector switch a couple of times here, see what we got. Okay, my source selection is giving me nothing. Stereo. Okay, if I put it in stereo normal mode, I start to get a little something there. Very weak and distorted. We know the electronics are good, so we probably have a bad control somewhere. The first step in troubleshooting is, of course, power. Make sure your power supplies are good. Well, we checked that already, so we know that's fine. The next thing I want to do is divide and conquer. So I've got a preamp and I've got a power amp. So I want to make sure that my power amp is working. So the way I do that is I take this screwdriver and make sure you know what you're touching here, and don't touch the chassis, please, is to turn it up and then touch the input leads to the power amp. That's good. Okay, so we know the entire output section is working great. That's not the problem. The problem is somewhere in the preamplifier. I took a piece of masking tape and I wrote on it the V number of the tubes in order so that I know which ones I'm looking at without having to turn the thing over. Now, using the schematic, I'm going to go through the system here and I'm going to find out where the break is. So we know that we have good audio at the interstage connection between the preamplifier and the power amplifier, which I will demonstrate. Left channel, right channel. Okay, now, safety first. If you're going to stick a screwdriver in there with your hands to induce noise into a stage, don't ever put another hand on the amplifier or touch it in any way while you're doing that, because if you get across high voltage, it can kill you. Don't do it, right? So I just make sure my body is back here, I'm not touching it. But in this case, I know what I'm touching, and that's the input lead to the main power amp. There's left, and there's right. We have good audio in both, right? Now, if I go to the phonograph inputs here, on the back side of this terminal block, I should have audio here. I have good, strong audio. Okay, now it's been pre-amplified, so it's going to be much louder, right? Left channel's good. How about the right channel? Nothing. Nothing at all. So the right channel is completely dead. We're looking at the underside of a 12AX7 tube, and pin 1 has high voltage on it. So that would be right here. That's pin 1. There's high voltage on this lead. The lead that I want to touch, which is the input to the tube, is right here on pin 2. So if I'm going to touch this, I want to make sure that I'm not touching this directly, but I'm going to follow this trace back a little ways and get away from that high voltage as much as I can. So I'm going to come down here and I'm touching this instead of this. Okay, I've got a little bit of sound there. Hear it? A little bit of hum in the right channel. So let me do the same thing on the left channel. There's a little bit of a hum there. Let's turn the volume up so we can hear it better. I don't know if you can hear that, but there is a little bit of hum there. So I actually have more sound on my right channel. So it looks like we have a couple of problems going on here. But one thing at a time. If you look at the bottom plate, it shows you exactly what's what on the inputs. So on the top I have right channel phono. Underneath that is left channel phono. Now here's the problem. When I touch what is supposed to be right channel phono, I get audio out of the left channel. Now what do you suppose that is? I checked the speaker leads and they're connected correctly. So somewhere in here is a miswire, probably caused by me. So let's see if we can identify what that is and get it fixed. In all of the years that I've been working on these amplifiers, I've never seen this before, and that is there's a flippage between the left and the right channel somewhere on the preamplifier board. We have to find out what that is, but first I'd like to get the channels working so that I can more effectively troubleshoot. I'm going to start with the right channel, and I'm going to start at the last stage of the preamplifier and work my way backwards. And I want to hear a hum at every stage from the right channel. So let's go here first. We'll take the last stage, which is right here. I should hear a hum out of the right speaker. Okay, that's good. So we know that everything from the power amplifier through the transformers, all the circuits, everything up to here is working correctly. Let's go back one stage and see how that sounds. Okay, I should hear a hum out of the right speaker. Oops, that's the wrong terminal. Let's try this one instead. Okay, good, that's working perfectly. Let's go back one more stage. This pin should hear a hum out of the right speaker. Oh, I'm hearing a hum out of the left speaker. Isn't that interesting? Let's see what's going on there at that stage. Well, we have a switching matrix. Could it possibly be a switch matrix problem? Is the switch set correctly? Now we know that we have a mode switch here, which gives us stereo normal, stereo reverse, left and mono. So let's check that. Okay, we're switched into stereo normal, so that's not the problem. Now, I'm going to do the same thing on the left channel and see what's going on, because one of these channels wasn't working at all, and we have to find out where that break is and get that fixed. So we'll start here at the output section of the left channel on the preamplifier. That is here, and that will be this pin. Okay, I'm hearing a little bit of a hum there, but not quite as much as I would expect compared to the right channel. So there's quite a lot more signal there. That is this pin here. Very low signal there, very low signal. We have a break in there somewhere. Now I'm listening here as I'm working, and I'm hearing a little bit of hum in the left channel, and I'm also hearing random pops and crackles. So something in here is intermittent. Okay, that's interesting. When I touched it at first, it wasn't very loud, and then all of a sudden it popped up and got really loud. And I'm just kind of looking at this, and that solder joint doesn't look very good to me. So let's power this down and touch up that solder joint. That really didn't look very good, so I'm going to go ahead and just resolder that pin. Right away I can still hear noise coming out of the left channel, so it's telling me something is still loose, but we'll get to that in a second. I want to see if this made any difference. So I'm going to the tuner input, which is here. Good and strong on the left. and I'm also hearing another hum on the left. That's not the way it's supposed to be, folks. It's supposed to be left and right. This amp is not acting like a normal amp. I mean, none of the controls are working the way they're supposed to. I took the separation control, which gives you either a wide stereo field, or you can collapse it down to virtually mono. That control is not working at all. And I've tried switching controls to mono mode, stereo mode, left mode, right mode, and it's not giving me results that I'm expecting to see. So I'm going to stop down now and do a very careful visual inspection of the preamplifier circuit board to make sure that I didn't induce some kind of problem with it, and then we'll come back. We know that I get crackling when I move the tube. So that means one of two things. Either the solder connections are poor, or there's a crack on the trace, or there could possibly be a pin that's loose. So I'm going to pursue the solder option first, and I'm going to touch up all the solder joints on this tube socket. All right, so I went ahead and I resoldered all the pins on that particular tube socket. What I did is I took all the old solder out, and what I found was the solder was kind of crusty and just kind of felt crunchy to me. Now, I've seen this before, where if you have a semiconductor or a tube that's been getting hot for a long, long time, it'll actually do something to the solder molecularly that makes it not very good anymore. And I found that by removing the solder from that and resoldering it makes all the difference in the world. So I'm sitting here talking to you, and normally I'd be hearing a bunch of crackling and popping sounds from behind me. I don't hear any more of that. So let's see what happens. I'm going to go ahead and give all these tubes another shake, and I did all the tubes, not just the one, but I did all the tube sockets, removed all of the solder out, replaced it with all brand new solder. So we should be good to go, unless there's a crack in the trace or maybe a bad pin. All right, so that one's good. That's good. 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 And good. So I'm not getting any more popping when I move the tubes around. That may have solved some of our problems. Not all of them, I'm sure, but it's a good start. Okay, with all of our tube sockets in great condition, I'm going to go back through and start doing the buzz test real quick. So again, we start at the interstage between the preamplifier and the power amplifier. Left channel's good, right channel's good. Now, I have the amplifier set to the aux2 input, and that would be here on the right channel, but I'm still getting sound on the left channel. And what is the left channel is coming out double loud. So we still have some kind of weird issue going on here. This amp is really making me work for it. And I spent a lot of time troubleshooting, and I finally found something. Check this out. So let's get the probe on ground here. And I am looking for, on V6, I'm looking at pin 6. Now pin 6 is a plate, and I should see some voltage on pin 6. Do you see any voltage there on pin 6? Because I sure don't. I'm seeing 0. Let's flip this thing over and have a look. So we're supplied here with 355 volts, but as you can see here, this resistor is wiggling around. It has 350 volts on it, but it's not soldered in. For some reason, the solder didn't take. So I'm going to go ahead and resolder that resistor, and we'll try it again. All right, guys, I went ahead and soldered that resistor back in. Actually, I put a brand new one in there, and I found one of the traces was cracked right there. So I went ahead and bridged across that with the wire of the resistor and some solder. So I've got music playing in here right now. Obviously, I'm not hearing anything. When I plug it in, I get a little bit of a hum, which is curious because I'm not getting any audio, even though audio is there. So there's still some deals going on here. Let's go ahead and check that voltage. So we'll go from ground, 2 pins and 6, 9, 8, 7, 6. And voila, there we have 204 volts. So now the plate on that tube is now hot. Okay, so I'm poking around with my scope probe trying to see what's going on here. And I get to the mode selector switch. Now watch this. Whenever I push on it, I start getting audio. I wonder if we have some of that sketchy solder up here on the switch. So I'm going to go ahead, shut it down, and resolder those connections at the mode switch. All right, guys, I need to show you this thing. I took the solder off of all the connections here on the mode switch, but look at this one in particular. So see that pad right there? There's supposed to be a solder fillet between the pad and the actual switch body itself. There's a little conductor right here, but look at the pad. That pad has no sign of solder on there whatsoever, which means the solder wasn't bonded to it. It was basically just kind of stuck there floating on the surface. And I've seen this before on this amp, a lot of really bad solder connections, and I think that whoever built this originally used the wrong kind of solder. I don't know where they got it from, but it was no good. The good news is I have resoldered nearly every single connection in this amplifier with new solder, and I'm going to go back as a precaution and redo the switches because it's the only thing that I haven't touched yet. Well, just as I suspected, solder connections were really bad up here. But I went ahead and I redid the volume controls, tone controls, and even the tone control networks. And I found the same problem on all those. Some of the connections were good, a few were okay, but most were bad. So that's all good. Now I went ahead and touched up around the tube socket here for the rectifier. So at this point, every single solder connection in this amplifier has been redone. So I think we're in good shape. Let's turn it on and see what happens. Smoke and fire. No, I'm kidding. Let's give this a moment to warm up here. And I've got some music plugged in, and we'll just turn this on and see what happens. Let me turn the volume down. It does stand a good chance of working. Let me just make sure the switches are set correct. Stereo normal, aux 2, separation is full, balance is correct, tone controls are neutral, volume controls down. Okay guys, this could be it. Let's see what happens. Some audio there. Okay, let's go ahead and plug the left channel in and see if we get lucky. Well, how about that? Okay, before we declare this a victory though, I'm going to unplug the right channel. Okay, I'm not hearing anything over there, so let's plug that back in. Unplug the left, nothing here. Nice, nice. Let's check the tone controls. Plenty of bass. Well, the tone controls are working great. Let's make sure that the separation control is doing its thing. The separation control is kind of a weird control that you don't find on modern equipment. Basically what it does is it goes anywhere from full stereo to full mono and anywhere in between. It's working good. Okay, right channel balance. Left channel balance. Let's go to stereo reverse. That's working good. Left channel in both speakers. Right channel in both speakers. This is a really old recording where they used to separate the instruments. That sounds really weird with only one channel going. All right, well, I've tortured my wife enough. She's back there holding her ears. It was pretty loud in here. So I've got to say that it was bad solder connections that ails this amp. So those are all fixed. It's making music now. And I don't really hear any scratching in the volume control. That's good, because usually they'll scratch a little bit. Let's check the tone controls. Now they are very clean, very clean. So if I find clean controls, I will not shoot them with contact cleaner because there's no reason to. And I don't see any reason to shoot these. Now I did shoot the selectors because they always get noisy. They always get dirty. It's just the way they are. They're switches and they're open air switches. But I like what I'm hearing here, so I'm going to go ahead and set this thing up on the bench and let it play for a couple of days and just make sure it's working good. I know the owner will be happy when he hears it finally. And one more thing before we go. I touched this wire here and there was a big arc flash inside this cover. This is the power switch. And I thought, well, that's not good. So I pulled it apart, looked at it, and here's what's happening. Do you see this coil spring right here? This is supposed to be kind of a flexible strain relief. Well, what it was doing is, if you look down here, you can see that it's soldered to ground. And what it was doing is laying over and touching one of the power leads that the switch is switching. That's not good. And it's really sketchy. So if you have one of these, you may want to open this up and have a look here, because that's a real problem. So what I'm going to do is try to shorten up this spring a little bit and get it out of harm's way. All right, so I'm going to take my needle nose pliers and just grab a hold of this. And I want to rip out several turns, probably until I get down to where it's actually insulated. Okay, let's do one more turn there. And now we'll just go ahead and cut that. Now, there's no way that that's going to get up in there and harm anything. So I'll put this back on here. And the Heathkit directions, they say, of course, to solder that. So let me get my solder out. And I'm only soldering at a couple of spots because I want to be able to take this apart later if necessary. So I'm just getting it nice and hot, putting some fresh solder in and just dragging it there. I'll come up here and do the same thing here in 2 spots. And that should be good enough. Now our wires are sticking out just a little bit, but they're not conductive. And there is a little bit of an insulator in there so it won't rub against anything and break. All right, guys, that's it. Thanks for watching.